As Thomas said, my name is Dmitry. Thank you very much. I appreciate that can be part of this conference. And thanks, Thomas. I think he's the greatest host I have ever seen because I have never heard that much of the F words during 1 minute, maybe only in a Pulp Fiction movie. So, as Thomas said, today I'll talk about SS7 insecurities, and I'll try to give you a kind of new vision of security and insecurity of mobile communications. Maybe you already know, SS7 stands for Signaling System number 7. And this is the system that gives intelligence to mobile networks we use today. But history of this protocol stack started long ago, I guess somewhere in the 80s. And it first was built for fixed line communications. So it was used for telephony a long time ago, during the time when it was a very closed ecosystem, a so-called walled garden. And that time, signal system is supposed to be a network that interconnects only a small amount of telephony providers, and no one can get access to them. But right now, things change a bit, and SS7 is not more that kind of network with mutual trust in it. Because today, you all know, today is the day of unified communications, and we do not have that amount of specially built hardware platforms for telephony anymore. Today we just built a software that runs on the x86 compatible processors, and many network functions are just right now just a software on the top of some operating system. And since then, we already use common interfaces for network connectivity, just like RG45 and, of course, TCP/IP protocol stack. And since we use TCP/IP protocol stack, we get the IP connectivity all around the globe. And this is the example when there is no more walled garden in telephony anymore, and no more walled garden in mobile communications as well. Because right now, any of you can prove it. You can just use a shortened search engine, type things like GGSN or maybe port 2123, which is related to GPRS tunneling protocol in the search string, and get the following results, which meaning that there are a huge amount of GGSN nodes exposed to the internet. And what is a GGSN node? It is actually kind of just a simple IP router which interconnects from the one side. It has an interface that connects to the mobile core network, and on the other side it is connected right to the internet. And if you look closely at it, you can see that there are sometimes even management protocols of GGSNs exposed to the internet. So this is sometimes this is due to some misconfiguration of this equipment, but sometimes this is just a normal case. So tomorrow will bring us even more sophisticated mixture of technologies, because today there are a few paradigms on the horizon called network function virtualization and software-defined networks. And one day, all the network infrastructure will be located on the data center. This will be very soon, I guess. So, nevertheless, some type of old technologies are still in place because sometimes they manage to evolve, like the one SS7 actually is. Because SS7, as I told you before, was built for fixed communication telephony lines. Then it evolved to better suit needs of mobile communications for GSM network for the first time. And then it was upgraded one more time to SIG2N protocol stack to be used over the IP networks. So today, for security researchers, this is a kind of time machine, because you can use very simple software, and you can use protocol stacks available on the internet to get knowledge of the SS7 network right now. And this is the problem that SS7 brings to mobile communication security today. So, in a nutshell, just a few words to sum up what is SS7 actually is. SS7 is a type of network which interconnects mobile operators today, And it is used to share different type of information. For example, short messages travel across SS7 network when you send something in roaming. Encryption keys as well travel across the SS7. And you understand this is kind of critical and confidential information, and this shouldn't be gathered by some bad guys. So it will be no good if someone with bad ideas get access to this information and get access to this network. And 2014 was a very good year for SS7 security, because there were a huge amount of security reports and many talks on the security conferences about SS7 security. And even Washington Post wrote an article about security, about secret possibility of secretly tracking mobile phone location. So someone can track where you're actually situated and how you locate during the time. But the thing is that here in telco world, we call this positioning, mobile subscriber positioning. And this positioning is not actually the worst thing that is possible for attackers in SS7, because with usage of just legitimate SS7 messages, attacker can actually perform denial of service attacks on subscriber and on different network elements, as well as withdraw money and can get your short messages and even intercept your voice calls. So today, SS7 is a kind of a source of security issues. And I will tell you about this kind of topics. I'll explain you how the attack of USSD money transfer works, how can an attacker intercept short messages, and perform denial of service on mobile switching center. And as well, I'll show you a demo video of fraud keys in an SS7 network. But excuse me for this, I have to give you a brief description of mobile network and network elements, because you need to know all the type of network nodes that are in place in mobile network. So this is the example of very simple infrastructure of mobile operator. Here we can see the radio part, where is base station controllers and base stations called node Bs and e-node Bs and LTE network situated. We also have a mobile switching center and VLR. Mobile switching center is actually the device that places calls on the network, and VLR is the database that holds information for mobile subscribers that are currently served by this mobile switching center. We also have a gateway mobile switching center, which is used for processing incoming calls. Short message SMS center, I guess it's clear. And HLR, which is a home location register. It is a database that holds profile for all the subscribers, home subscribers of one telecom operator. So this is the database of subscribers. And of course, we have some system for charging money. This is the billing system. Since this is a non-IP network, there are some kind of different identifiers so that these network elements can address each other. And the main identifier called global title, it looks exactly like telephone number. Another one is MSI SDN. When you ask your friend for his phone number, you're actually asking for MSI SDN, because MSI SDN is actually a phone number of your gadget. Mobile station roaming number is exactly the same MSI SDN, but used only temporary during switching calls on the MSC. And here is also international mobile subscriber identity, which is actually the unique identifier of your SIM card, because there is no telephone number located on your SIM card, only MSI. MSI SDN is a kind of information only telecom operator knows about you. There is no MSI SDN on the SIM card. And when we speak about SS7 security, this kind of question usually arises how to get in actually, because this is supposed to be a closed ecosystem. But today, any operator is not only a mobile operator, it is also an operator of mobile internet, maybe some voice over IP services and internet access. So there are a huge amount of different packet switched core and IP multimedia subsystems around it, as well as many type of access networks like LTE, Wi-Fi, WiMAX, and PON and DSL technologies. And of course, there are two types of networks for roaming exchange. This is the GRX and IPX, which is used for interconnection of mobile operators to share your internet traffic while you're somewhere abroad in roaming. And of course, there are type of networks where administrators actually located. This is the remote support and operation and maintenance teams networks, which also have connection to the CS core. Of course, the IT network, because each telecom operator is just a corporate. It has accountants, it has marketers, and all that stuff. They must sit somewhere, and more than that, many CRM and ERP systems usually located in the IT network and have some kind of integration with billing system in the CS core. And of course, we usually have internet somewhere by our side. And the thing is that amount of traffic among all of these networks is huge at the moment, and there is very difficult to apply some kind of filtering, and you can never know from which side actually attack can arrive. So today we will try to concentrate on the attacks that comes from SS7 network, but you should realize that SS7 is an international network all around the globe, and in case one day some attacker can compromise any telecom operator and his CS network, he will automatically get access to any other CS core of all other telecom operators, since there are no firewalling in place in SS7 network at the moment. So the first type of attack is an SS7 interception. This is not the type of SS7 interception that is placed on the radio interface. This is SMS interception using signaling systems. So the victim can be somewhere in Russia, for example, and the attacker can be somewhere in South America. The location doesn't matter. And the first thing attacker should do, as usual, is to collect some information about the home network of victim. On this slide, victim will be the subscriber B, and our attacker is located somewhere in the international SS7 network. So for the first step, he will introduce himself to the home network of victim subscriber as a short message center. So he will send a special MAP protocol message called send routing info for SM. And actually he's telling, hello, I'm a short message center, and I have some short message for subscriber B, so please tell me his location. Because this mobile communication and subscriber B can move all around the globe, so SMSC need to find his location. This message arrives on the gateway MSC, but since gateway MSC doesn't hold this kind of information, he will forward it to the HLR database. And HLR will respond with the following info. He will provide attacker with identifier of HLR, his global title. He will provide attacker with global title of MSC VLR that currently serves subscriber B, as well as IMSI identifier of subscriber B. So now attacker represents himself as a mobile switching center who wants to serve subscriber B. This is the situation and procedure which take place, for example, when subscriber B moves to another country, to the roaming partner, and under the serving of another MSC. So attacker just gives the home HLR the following information, like I'm the new MSC VLR who should serve subscriber B at the moment, and please just store this information in your database. This is enough for HLR since it has no source of information whether or not this MSC is real. So he will just store this information that currently subscriber B is served by the new MSC. Later on, when someone wants to send a short message to subscriber B, short message will be processed on the SMS center. But since SMS center doesn't have information about subscriber B location, he will ask for this on the HLR database, which at the moment stores the ID of the attacker's MSC. And he will forward this information right to the SMS center with the wrong global title. Not the wrong, but the global title of the attacker's MSC. And short message center will just send your SMS right to the attacker. So at this step, you should understand that this is that easy to get your short message while using SS7 signaling. And anyone with access to the SS7 network can do it just fine. And today, of course, today short messages are not used for chatting, I guess, because this is a kind of ancient technology. But today, short messages consider it to be a kind of confidential communication channel because one-time passwords travel across short messages. Different notifications from online banking system also delivered through short messages. And of course, if someone would like to compromise your Gmail or Facebook account, he just needs your email address and your phone number, and he can get you access to your social network. So this is it. Now you know how it is easy to get your short message. The next attack is about USSD codes. I don't know, maybe here in Singapore you use USSD codes for some operations or not? USSD codes when you just dial, for example, asterisk, number, and a hash sign. For example, to check the account information. You use it, yeah? Yeah? You all know what USSD, yeah? No. Well, I guess you know that. So, on the first step, attacker will also need to collect some information. For example, for subscriber B. On this side, let's imagine that subscriber A will actually be also an attacker phone, and subscriber B will be our victim. So attacker will use exactly the same message, send routing info for SAM, gathering information about who is actually currently serving subscriber B. But this time, attacker only wants to know the global title of HLR that stores information about subscriber B profile. And since attacker can get it, he can send direct USSD process request to the HLR database with following string, for example. In Russia, asterisk 100 hash sign means to ask your HLR about your account information. How much money do you have on your phone? HLR will ask for this information to the billing system and will reply to attacker with just some message. By the way, Wireshark already has all the dissectors, so you can look at these messages. And on the next step, attacker can just send a special USSD request. That depends on your telco operator, because some operators allow you to transfer money using USSD codes from account A to account B and otherwise. For example, here, let's imagine that 123 command is the command to send money from your account to the number that follows the asterisk sign. Since for HLR there is no need and there is no possibility to verify the source of this USSD code, he will just process it, will push some signals to the billing system, and money actually will withdraw from the subscriber B to subscriber A account. On this stage, there is a kind of SMS notifications usually sent to the subscriber B, but in case the first type of attack with SMS interception already took place, subscriber B will never get short messages about this money transfer. So later, depending on the amount of services and goods that can be paid using your telephone account, there are different ways to monetize this attack. And let's speak now about the mobile switching center denial of service. Well, I guess by now you already know what will be the first message sent by the attacker. It will be send routing info for SAM as well. So right now, attacker wants to perform denial of service on the MSC VLR that's serving some subscriber B. He gets the information out of HLR about global title of this MSC VLR, and after receiving this information, he will represent himself as HLR of some roaming partner. And let's say that this HLR will tell something like this: hello, I'm an HLR and I have a call for subscriber B. So would you mind please provide me with mobile station roaming number so I can place this call on the network? And roaming number is a kind of temporary telephone identifier which is used only to switch calls. So its lifetime usually maybe a second or 2 seconds. MSC VLR will provide this information. He will use one of the MSRNs available in his pre-configured pool, and he will give it to the attacker who is presenting himself as an HLR at the moment. The thing is that in case there are some technical issues or errors on the network at that moment, there can be a situation when all the mobile switching station, mobile station roaming numbers are already leased to some subscribers, and there are no more of them in the pool. So for this reason, we have special default timeouts to release mobile station roaming numbers. But as you can see, they are huge, because from 30 to 35 seconds, this is too much. Because in real life, MSRN is needed only for maybe just a couple of seconds. So if attacker will be lucky enough, he can try to ask many times to provide roaming number for this exactly subscriber B. At this moment, for MSC VLR, it actually doesn't matter that subscriber B can simultaneously hold maybe 5 or 6 phone calls. He will still provide roaming numbers for this exact subscriber. And one time, finally, attacker will send the last provide roaming number message, and MSC VLR will reply with the error message saying that there are no more roaming numbers available in the pool. This is the, if you see, this is the example of error code. And let's imagine what will happen if in this moment some real HLR will try to place a call on the network. He will, to some subscriber, for example, to exactly the same subscriber B, he will send to this MSC VLR exactly the same message, asking to provide mobile station roaming number, and he will get the reply, the error message that there are no more roaming numbers available. And this means that there are actually no incoming calls can be placed on the network at the moment. To understand the huge problem with this denial of service is that one mobile station, one MSC can simultaneously hold maybe 500,000, 1 million, 2 million subscribers. So this will be a huge impact on the provider network, because simultaneously maybe 1 million of subscribers cannot receive incoming calls. Here is it. And now to the fraud case in SS7. As I told you before, SS7 is a kind of network that's supposed to be a trusted environment. But time goes and things changes, and today there are so many companies that actually have access to SS7 network. There are content providers, small telco operators, different providers and vendors of value-added services, and etc., etc. That there are a huge amount of guys that you just cannot trust, neither. Because, for example, they can perform this type of attack like uncharged calls. Uncharged calls. Let's see on it. So here, the attacker still somewhere on the SS7 network. Yeah, he is in SS7 network. The victim will be the green cloud, our home mobile operator. So on this slide, subscribers A and subscriber B are actually the phone numbers that belong to the attacker. So attacker will start the fraud with exactly the same message, send routing info for Sam, saying that he is should message center, his global title is the following, and he's asking for location of subscriber B. HLR will reply with the following information, revealing his HLR global title, MSC VLR global title, and subscriber B IMSI. Then attacker will try to spoof MSC. So he will send update location message saying that he is the new MSC VLR who wants to serve subscriber B. Okay, this is pretty fine. So HLR will just get this information and store in its database. So at the moment, attacker seems to be serving subscriber B. Later on, when some subscriber, for example, subscriber A, want to call subscriber B, all the incoming calls are served on the gateway MSC. So it will receive call for subscriber B. But since gateway doesn't know where B located at the moment, he will ask this information to the HLR. For example, to get the information about account, whether or not there are money on the subscriber A and subscriber B accounts. So he will ask the home location register for the sent routing info, and HLR will ask the same info to the MSC that currently serves subscriber B. He will reply that everything is fine, subscriber B, he will lie actually. At the moment, attacker MSC will lie to HLR because he will say that subscriber B is in home network and should be charged just like this is a local call taking place. So this is fine for HLR, this is fine for gateway MSC, and this information will be shared with billing system, which will charge subscriber A just like for a local phone call. On the next step, gateway MSC needs a mobile station roaming number to switch the call. So he asked for MSRN to the HLR. HLR doesn't store this kind of information, so he will ask mobile switching center of attacker for MSRN. And of course, he will reply to us with some mobile station roaming number. HLR will forward this information to the gateway MSC, and gateway will use it to place a call on the network, to forward it, for example, to Italy. Now the question, why the hell this phone call goes to Italy if it was, for example, local call between two phones, maybe somewhere in Russia? This is because we should look closely at the mobile station roaming number that was provided by the attacker. This is the prefix 39, which is related to Italy, but this can be a Cuban phone number or maybe some premium rate number. The thing is that today, none of the telco equipment actually try to check this mobile station roaming number, neither. So just any roaming number will be fine for HLR, and he will try to forward a call to it. Let's see the demo now.
Смотрю баланс, да?
Okay, on this video you'll hear some Russian speech and some Italian speech, but don't be afraid of it. So here, black phone will be subscriber A and white one will be subscriber, A and B, yeah. White is a B. So I will use USSD code to check account information for subscriber A. Let's see. Okay, we have 122.90 rubles. This is the account info. Now let's try to perform a local call to check how much it costs to us. +7 is the country code of Russia, so this is the local call from phone A to phone B. Okay, waiting for call, it is processed. Okay, so we received the local phone call. Now let's wait for maybe 10 seconds for billing system. It is enough to charge us.
10 секунд.
Okay. And I'll stop this phone call. Now let's try to make an international call from the same subscriber A just to find out how much it costs for us to call to Italy, for example, for the difference.
121.30.
So now we can see that the local phone call cost us
Так,
only
набираем международный, да?
1.60 rubles. Now perform an international phone call to Italy.
Не, сейчас международный просто, чтобы проверить это.
Actually, I don't know why we blurred these digits because you still can see the buttons I'm pushing. Yeah. Sorry for this. Yeah. Okay, this is the Italian number.
Positive Technologies, buongiorno.
Yeah. Buongiorno. So this is a phone call to Italy.
Buongiorno.
Now let's check account information one more time.
И еще
How
раз
much money we
баланс.
spent on this call?
У меня на экране было уведомление от Лука.
М?
Ну, Лука было уведомление.
Okay, this
Так,
call
есть.
cost us 30 rubles.
91 снялся.
Now let's
Давай
try to perform an
передать,
attack.
это пошло.
So we will try to redirect incoming call. For this, we will use subscriber B as a mobile phone number which will be served by our MSC. So here is victim mobile is actually the mobile phone of the subscriber B, who will be served by our MSC VLR, because right now we are the attackers. And forwarding number will be the Italian number that we would like to direct phone call to. Here is the numbers. Okay, and just press attack to initiate communication. On the back, on the Wireshark screen, you can see, let's say, can you read it? Or it is a bit blurred. There are SRI for SAM messages as well as the update location message for subscriber B. And now we would like to perform a so-called local call from A to B, but we are actually want it to be redirected right to Italy. Here's the message. We've provided roaming number that right now is actually an Italian
Что
number.
значит снимать трубку?
Now waiting for reply.
Positive Technologies, buongiorno.
Okay, so as you can
Buongiorno.
see, we reached Italy one more time, but the number we dialed is actually with a +7 country code, so it was in Russia.
Так, и еще раз баланс.
And now one more time, let's check our account information. Here is it. This call
Yes.
cost us
Всё.
only 1.60 rubles. So this is
Hop.
charged just like a local phone call. Let's see what it means for mobile operator. In this situation, call from A to B while at home cost 1.60 rubles. Call from A to Italy should cost us 30 rubles. But since we performed this type of attack, the attacker profit possibly will be 28.40 rubles. So this is actually the way to perform international calls on only 5.3% of original price. Of course, we do not know in this situation how much money actually the operator will lose, because, of course, for telco, the cost of international cost doesn't seem to be 30 rubles. But anyway, he will lose some money because he need to pay to the transit operator. Well, I guess this is all with fraud cases. And this is, the slide is a type of conclusion, because SS7 is not the only problem of mobile communications today. There are still problems with GPRS technologies and new diameter protocol, which one day will be used instead of SS7. And there are also a huge amount of vulnerabilities in SIM cards and Java applications running on them. We are trying to do research on all these fields, but still there are a huge amount of information needed together just to make telco more safer. Well, I guess this is it for me. Thank you. In case you have any questions, please.
Must the attacker be part of employee of telecoms company, or can be anybody?
Well, yeah, most of the time, this is just a kind of one of the engineers that can get access to this CS core. But since to date, just to have less cost on the operation and maintenance of the core systems, there are usually technical support from different countries. So there is a huge amount of technical staff who can get access to this network, yeah.
For the SMS interception, if the calls are encrypted, will it still work?
Excuse me, I didn't get the question. Short message gateway?
Yeah, for the short message interception problem,
Yeah.
if the messages are encrypted, will the attack still work?
Well, actually, if the message is encrypted, then you should somehow decrypt it, maybe to use, well, anyway, yeah, you need to decrypt it, but you can still intercept them. So you'll get the raw data, but you need to decrypt to get the original message, yeah. But I don't know, there is no technology to actually encrypt original short messages. This is some kind of, in other technology, maybe using GPRS with encrypted data in it.
Kind of related to the first question, are there any service providers where I can just buy access?
Where I can get access, yeah?
Like, is there any services on the internet right now where I can just sign up and get SS7 access?
Well, you can sign up and get access in case you are a telco operator, for example, if you buy a license for telco, for providing telco services. In case you manage to get in touch with some telco operator and tell them that you're a kind of new value-added service provider. So there are a huge amount of ways to get access to the SS7. I myself try to get access by providing information that I'm a kind of value-added service provider who is gathering information on IMSI checking for online banking. So there are ways to get legitimate access to the SS7, as well as non-legitimate. Yeah.
Just one more question. In the call redirection, does the person whose number you redirected to the Italian number, do they get billed instead?
No, they won't be billed. In this situation, the subscriber B will not bill because he actually get the incoming call. And since billing system use information provided from attacker, for billing system, it seems just like a local call. So the only one who will be billed for this international phone call will be exactly the operator, because he have to pay to the transit operator as well.
Anyone? Any more questions? No? Dimitri, thank you very much. All right,
Thank
good.
you.